So instead of just finding the inverse of a function, let's say I were to ask you to find the inverse and graph it. Okay, so this goes, this is well before anything dealing with transformations, okay? We're just dealing with stuff that we saw in the previous video, which was finding the inverse of a function and learning how to graph it just based on that. Okay, so first, what I'm going to do is I'm going to give you an example function. Okay, let's say I give you something like this. Okay, first I want you to find the inverse of it, and then I'm going to ask you to graph the inverse. Okay, I think what's important for us to do first is find the inverse algebraically first. Okay, so that involves us doing our whole flipping x and y thing and solving for y. So let's do that. I'm flipping x and y here, and then I'm going to solve for my new y, which means I'm going to divide by, I don't know why I made that negative, divide by 3. So I get y squared equals x over 3. So my inverse function is going to be the square root of x over 3. Okay, let's keep that in the back of our mind. I'm going to keep the original function here still, and I'm going to have my inverse on the side. Okay, so I've got root x over 3. F inverse of x equals root x over 3. Okay, now that I have both of them, what I'm going to do is I'm going to recollect, okay, well, my parent function graph of x squared looks something like this. Okay, it's a parabola. And in fact, when we restrict our domain on the inverses, we're only talking about the right-hand side, okay, which is a half of a u going up. Okay, the inverse, what it does is it graphs, it takes the graph of your original and it reflects it across the y equals x line, meaning that my square root function, square root of x, looks something like that, where it flattens out instead of shoots off to infinity. Okay, so that's the root x graph, that's the x squared graph. My goal is to sort of graph these in a way that's easy to interpret. I think graphing the original function's easiest. Okay, a parabola that's 3x squared starts off at the origin. It's going to shoot off to the right and to the left up to infinity, but we're only going to focus on the right-hand side. So your goal in this, I think, is to make like a little table. Okay, let's pick numbers that are to the right of 0, because we're going to be focusing on the right side of the graph. Let's do 0, 1, and 2. Okay, I already know what 0 is because we're starting off at the origin. If I'm plugging 1 into here, I get 1 squared, which is 1, times 3 gives me 3. Okay, now we're going to do 2. Oh, that's cut off down there. Okay, let me make this a little nicer. I'm going to have a second section here. I'll just put the table over here for now. All right, 0, 1, 2, 0, 3. So if I plug in 2 into here, what am I going to get? I'm going to get 2 squared, which is 4, times 3, which is 12. Okay, so let's graph that first. 0, 0 is already good. 1, 3 is about like right there. 2, 12 is somewhere up there. I've got my half of a parabola. That's the right-hand side. Okay, now I'm going to graph the table for my inverse. So let me get x and f inverse of x here. I'm going to do the same thing. I'm going to plug in 0, 1, and 2. But if we remember correctly, an inverse function takes your points and it flips the coordinates. So I'm actually going to re-put down what we had for the other one here. We had 0, 1, 2. I said that was 0. That's 3 and 12. Okay? And ultimately, your x column goes where your y column is. And your y column goes where your x column is. That's the pattern that you can use for finding the inverse table. Okay? I'm going to graph the inverse in a separate color. I'm going to start off at 0, 0 still. I'm going to go to 2, 1, which is about right here. And then I'm going to go to 12, 2, which is somewhere over here. And I've got the graph of my inverse. Remember, there's a little bit of a curve to it. It's not a perfectly straight line. That's my square root graph. So this is the root x over 3 graph. The one going up is 3x squared. That's how you graph the inverse of a quadratic. Okay. We're also going to do one with a cubic. But your main focus is going to be flipping the x and y here. Okay. I picked 0, 1, and 2 because it's just the right-hand side of the graph, and your inverse table flips the values. Okay. So let's practice it with, I'm actually going to give you one to practice first. So let's say I give you a function like negative 2x squared. Okay, and I ask you, find the inverse and graph it. Okay, so find the inverse and graph it. Okay, so I'm going to let you try that first, see what you get, and then see if your work matches up with mine. So for starters, algebraically, I'm going to do the f of x substitution for y, and then I'm going to flip x and y, and then solve for my new y. So I'm going to divide by negative 2 on both sides, giving me y squared equals x over negative 2. I'm going to restrict my domain to x is greater than or equal to 0, so I'm only going to focus on the positive square root when I square root. This is negative x over 2. This is my inverse function. Okay, now that I have my original function and my inverse, what I'm going to do is I'm going to set up a table that corresponds to both of them. So I'm going to rewrite this over here. Let me actually get rid of this too. So I've got f inverse x equals square root x over 2, just like that. Cool. All right, table 1 is going to be my original function table. Table 2 is going to be my inverse function table. Okay. Table 1, since I'm dealing with a parabola, I'm going to go to the right of 0, 0, 1, and 2. Okay. I know that those are going to be my y values for my inverse, so I can put those down if I want to. If I plug in 0 into my original function, 0 squared 0 times negative 2 is 0. 1 squared is 1 times negative 2 gives me negative 2. 2 squared is 4 times negative 2 is negative 8. I'm going to take those x, or those y values, and I'm going to put them in for the x values in my inverse. And now I'm going to graph these. So first, I'm going to start off with the original function. I start at 0, 0, 1, negative 2, 2, negative 8. Okay. Since it's a parabola, I'll actually draw this a little more realistically. Okay. Since this is a parabola facing down, it's going to have a slight curve to it. That's going through that point. That's fine. Now my inverse, I start off at 0, 0. I'm going negative 2, 1. It's going to be over here. I'm going negative 8, 2, which is over here. Okay. That's giving me a graph that looks like that. Now you're probably asking, okay, well that doesn't look like it's reflecting across the y equals x line, which is this way. But in fact, it actually is. So since this negative is inside the square root, that corresponds to taking your square root graph that looks like this and flipping it across the y-axis. Okay, and that's with our little transformations. Okay, so the graph should look something like that, and we see that our graph is pointing in the right direction. It just doesn't seem like it's correct, but that is. Okay, so that's another example of graphing the inverse of a quadratic. So let's go into a cubic. So let's say I've got a function like 2x cubed. Okay, and I want to find the inverse and graph. So if I'm wanting to find the inverse and graph it, what am I going to need to do? First, finding the inverse algebraically, I'm going to do that first. 2x cubed. I'm going to switch x and y. 2y cubed. Solve for my new y. So I get x over 2 equals y cubed, meaning y is equal to the cubed root x over 2. I don't need to worry about restricting the domain because it's a cubic. So I've got two things. I've got my original, and I've got my inverse. Okay, so I know my inverse is f inverse of x equals cubed root x over 2. Now that I have both of the functions, all I need to do is make my tables, and I can graph it. So let's do the original function first, and then my inverse function. Since I'm dealing with a cube root this time, it has a left side to its graph. Okay. So I'm going to instead of doing 0, 1, 2, I'm going to do negative 1, 0, 1 for both. And I know those are going to be my y values on my inverse. Okay. If I plug in -1 into my original, I get -1 cubed, which is -1, times 2, which is -2. Plugging in 0 gets me 0. Plugging in 1 gets me 2. And in fact, the y values will be your x values in your inverse. Now we can graph it. Okay. Start off with the original. I've got -1, -2, which is about right there. 0, 0 is about right there. And then 1, 2 is about right there. This looks like it's on a straight line, but in actuality, if we remember, the cube root or the cubic graph has a little bit of a curve to it. Okay, that's the graph of the cubic part. Now we need to graph the inverse. The inverse graph starts at -2, -1, which is about right there. It goes to 0, 0, and it goes to 2, 1. Again, it looks like these are on the same line, but this is a sideways S. Flattens out as you go to the top of that one. So inverse graph, regular graph, and that's how you graph the inverse of a cubic. Okay, so I'm going to give one more example for you to try, and we'll see if it matches up. So let's say I give you something like f of x equals 2, or let me do a different number here, 4x cubed. Okay, your goal is to find the inverse and graph it. Okay, so I'm going to let you try that first, and then we'll convene, and then we'll see if you get the right answer. Okay, so f of x, I'm going to change that to y, 4x cubed. I'm going to switch x and y, solve for my new y. Should get something like the cubed root of x over 4. Okay, that's going to be my inverse. Okay, so I'm going to write it over here with f inverse notation. F inverse x equals cubed root x over 4. Now I can get rid of all this mumbo jumbo. Now I'm going to graph this, okay? I've got a table for my original, and I've got a table for my inverse. Since it's a cubic, I'm starting -1, 0, 1, and I know my y values are going to be that on my inverse. Okay, if I'm plugging in -1 into this, I get -1 cubed, which is -1 times 4 gives me -4. 0 gives me 0. 1 gives me 4. I'm going to switch these two for the inverse. This is going to be -4, that's 0, and that's 4. Now I have every tool I need to be able to graph this. Okay, so I've got -1, -4 about right there, 0, 0, and 1, 4. Again, these are not on the same line. They're on the same function, just not on a straight line, so you got to just give it a little bit of a curve. That's what my cubic graph looks like. Now I need to graph the inverse. So I've got -4, -1 starting out, which is about like right there. I've got 0, 0, and I've got 4, 1. Again, these are not a straight line. They've got a little bit of a curve to it. That's how you graph the inverse of a cubic and a quadratic. And you definitely will see something like this on Thursday.